Hello, algebra students. Today we're going to learn how to factor different types of trinomials. Trinomials where the lead coefficient is not 1. I'm pretty sure this technique would work for if it was 1, but this is actually new to me. I've never tried this, but I remember last year another teacher, I think a teacher at Viz, swearing by it. They said he never tried it. They did it this way. The kids liked it a lot better than the way I normally do it. So I'm going to go ahead and show you this technique and see if this turns out, if we have better success with it than I might have had with my other technique. Always open to new ideas, looking to try new things. All right, so what we need to do here is we need to look at this lead term here and this ending term here. We need their product, which of course is 48, right? 2 times 24. Okay, now we're going to find two numbers, two terms that are going to add up to 16x. Okay, the only trick is that we need them to be uh, factors of 48. Their product needs to be 48. So it might be really smart to list the factors of 48, 1 and 48, and then 2 and, 24. Okay, 3 is going to work, and I think that's going to be 16, right? And then 4 and 12. 5 will not go in, and 6 and 8 will. All right, and I'm seeing a 4 and a 12. What I'm going to do is I'm going to rewrite this trinomial into a polynomial with 4 terms. And I'm not going to write 16x. I'm going to break the 16x up into a 4x and a 12x. So I'm going to go 2x squared plus 4x plus 12x plus 24. And now I'm going to treat this like a problem that we factor by grouping. So we're going to make sure these first two have a GCF, and I already knew they would because of the way I wrote them in order, but make sure the second pair has a GCF. Now I'm just going to do factor by grouping. I'm going to GCF the first pair, and I'm going to get 2x times the quantity of x plus 2, and then I'm going to pull out a 12, and then I'm going to have an x plus 2. And there's that x plus 2 is common to both groups. See it right there? It's a common factor. And so what I'm going to do is pull that x plus 2 out, and that'll leave me with a 2x plus a 12. Now, it would normally be done, except I noticed something about 2x plus 12. There's another GCF hiding in there. And really, I could have pulled out that initial GCF to begin with, but it's okay to pull it out now. The GCF of 2x and 12 is 2. So I'm going to factor out a 2. I'll stick it out front. Have 2 times the quantity of x plus 2 times the quantity of x plus 6. Where did the x plus 6 come from? Because I factored out a 2 from that second quantity. And there, that trinomial is completely factored. And it's actually a pretty easy way to do it. I just listed the factors of 48. I found 2 that added up to 16, right? And why do you suppose I was adding? Because that term in the back was a plus, so I need that Wendy's double stack. All right. Okay, let's see here. Let's scroll on down to this one. Tell you what, I'm going to look for a GCF first on this one. I've got a 12x squared, 19x, and a 5. I do not have a term that's common to all three. So I'm going to get the product of the 12 and the 5, which is 60. So I'm going to list the factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, of course, because that's how I got 60 to begin with. 6 and 10, 7's not going to go in evenly. 8's not going to go in evenly. 9's not going to go in evenly. There's all my factors. Now, it's a plus in the back, so I'm going to add my two factors to get 19. And look at that, I got a 4 and a 15. That makes 19. So I'm going to rewrite this trinomial. But instead of writing 19x, I'm going to write a 4x and a 15x, because 4x plus 15x is 19x. So I'm going to get 12x squared plus 4x plus 15x plus 5. Now, it wouldn't matter if I did the 4x first or the 15x first, but notice, just a little bit of thought, I'm going to get a GCF in the first pair if I do it this way, and a GCF in the other way. Okay, so it'll be a little bit easier. So I'm going to pull the GCF out of the first quantity, which looks like it's going to be a 4x, leaving me with a 3x plus 1, plus I'll pull a 5 out of the second quantity, and I'll have a 3x plus 1, and there you go. The 3x plus 1 is common, so I pull out a 3x plus 1. I'm left with a 4x plus 5, and there you go. Wow, I'm really liking this new method. I just thought about it the day I was recording this video. Geez, I should try this. I mean, when the person told me last year, I'd already taught it my way, and I didn't want to introduce another way, and I thought, well, maybe next year. Well, you guys are the guinea pigs, but I think you'll like it. In fact, if some of you go show your older brothers or sisters, like, Anna, Anna, you won't see this video for a while, but anybody in honors that I've had your brother or sister show them this technique, they might like it better. Okay, on this one, I've got 6 and 2, so I have 12. So I'm going to list my factors of 12, 2 and 6, 3 and 4, and the plus in the back tells me I'm adding. So I'm going to add to get negative 7. So it looks like a negative 3 and a negative 4. So I rewrite this guy, 6x squared minus 3x minus 4x plus 2. Okay, I'm ready to group. Remember, grab the sign with the 4 because it's negative. Stick a plus in between. And now I'm ready to GCF. So I'll pull out a 3x. I'll get a 2x minus 1. And here, I think I'm going to pull out a negative 2. And I'm going to get a 2x minus 1 when I do that. All right, looks like the 2x minus 1 as a quantity is common to both terms. It's a common factor. And there you go. You know, I didn't think you mentioned in any of the videos, I'm sure I mentioned it in class, but just to refresh, you could always check and see if you were correct by foiling. If you foil any one of these answers, you should end up with the trinomial you started with. Okay, let's do some where there's a negative. Now, if I do 10 times negative 14, I'm going to get negative 140, right? So the factors of 140 are 1 and 140, 2 and 70. 3 is not going to go in. 4 should. If I cut in half 70 and then 35, yeah. 5 is definitely going in. I think 28 times. You know how I did that so quick? I knew that 10 was 5 times 2. And I knew that if I took this 2 over here, I would get 28, 5 times 28. Okay? Because I know I have to have 5 times 2 times 14 to get 140. Whereas, 10 times 14 is 140. So I broke that down, and then I combined these two, and so I have 5 and then 28. Okay, just showing you a little math. Try testing this stuff out. It's pretty cool the more you do it. Okay, let me see here. Does 6 go in? Well, 3 is not going to go in, so 6 can't go in. 7 should go in. Looks like 20 times. There's a lot of factors here. Okay, 8 should go in. No, 8's not going to go in because 35 is not an even number. I can double 4 and get 8, but if I cut that in half, I get 17 and a half, and that's not an even number. Okay, where am I at? 9's not going to work. 10, of course, will work. Okay, I don't believe 11 will work. 12 can't work because 3 doesn't work, and I'm pretty sure 13 won't work, so there we go. All right, now we've got a minus back here. We need a subtraction problem that gets me positive 31. Looks like a positive 35 and a negative 34. So I'm going to rewrite this as 10x squared plus 35x minus 4x minus 14. I'm not sure why I grouped that way, probably because I could pull a 5x out of here and then a negative 2 out of here. But there is a GCF, so let's go ahead and do this. Grab the negative, make sure we put a plus in between our quantities. All right, I'm going to pull out a 5x and get 2x plus 7. And then I'm going to pull out a negative. I'm going to pull out a negative 2 because there's a negative that's common about. That'll give me a 2x plus a 7, and look at that, it's like magic. I get 2x plus 7, that's common. 2x plus 7, 5x minus 2, and oh my goodness, this is so simple. I think this is way simpler than the way I used to teach it. I'm so liking this. I hope you guys think it's easy. Got a couple more examples here for you. I'd like to show you lots of examples. I know the video is going a little bit longer, but I'd like to give you lots of examples on something new. All right, 6 times 24 is going to be 24. So 1 and 24, 2 and 12, 3 and 8, 4 and where am I at? 6, right? It's a negative in the back, so I'm going to subtract to get 5. Looks like a positive 8 and a negative 3. So I'm going to rewrite this as 6x squared minus 3x plus 8x minus 4. Now I know core of this is going, I'm just not sure how negative 3x plus 8 is the same. Well, all I did was break 5 up into those two terms. And where did I get those two terms from? By listing the factors of 6 times 4, 24. And after I listed all the pairs of factors, I subtracted because of that minus to get this middle number. All right, so now I can group, and I don't have to be as concerned about grabbing the sign because the 8 is positive. And I'll GCF out a 3x and be left with 2x minus 1. And then I'll pull out a 4 and get 2x minus 1. And then I'll have the quantity of 2x minus 1 times the quantity of 3x plus 4. And there you go. There it is. All right, one last one. The products of 6 and 2 is 12. The product of 6 and 2. Factors 1 and 12, 2 and 6, 3 and 4. I'm subtracting to get positive 1. So that'll be a plus 4 and a minus 3. 6x squared. Which one do you think would make the most sense to write first? The 3 or the 4? I'm thinking the 3. 3x plus 4x minus 2. I'm going to do my grouping thing. Group like this. Gonna pull out a 3x, 2x minus 1, plus pull out a 2, get a 2x minus 1, and the 2x minus 1 is common. Gonna pull it out and get 3x plus 2, and there you go. Pretty easy stuff. All right, that's your video for tonight. We'll get lots of practice tomorrow. Mr. Lawrence signing off. Good night, everybody.